How's it going, everyone? Welcome back to the channel. Today we're going to be talking about a very important topic when it comes to manufacturing careers, and that is control systems engineering. And the reason why it is an important topic today more so than ever before is a couple of reasons. So number one, on the end user side, every single facility that I've been going to in the last couple of months to couple of years, I would say since COVID, is looking for control systems engineers, control systems technicians, and people who are capable of designing general industrial automation systems, but also troubleshooting, maintaining them, and making sure that things operate smoothly. Number two, there's been a lot of desire, I want to say, to enter the control systems engineering field from professions like software engineering. So a lot of people have been laid off from different companies. They're looking to enter or at least understand what it takes to be a control systems engineer. But also there's been a lot of people looking to move up from electrician or technician, and they're seeking to understand a little bit better what are some of the requirements of control systems engineering, what does it take, what does it usually, I want to say, require to get into those roles. But also I've seen a lot of confusion from recruiters and users and also executives trying to find these people. As I've mentioned, there's definitely a lack of skill set on the OT side. So I want to clarify a lot of points as well as to what you should be expecting when perhaps interviewing, looking for, or trying to convince a control systems engineer to come work for you. All right, so let's start with the absolute basics. Control systems engineering has two, I want to say, key terms: control systems and engineering. So in a previous video, I talked about manufacturing systems. I basically explained everything that has to do with automation and what you could see on the plant floor. But what is a control system at the core? A control system, and the best analogy I can use is when you're driving your car, if you're looking to go at a certain speed, you're going to press the gas pedal. And the control system is basically going to recognize how much pressure you're applying and then send that vehicle to go at a specific speed. And despite the vehicle going downhill, uphill, or on a flat line, you will see that the vehicle is going to maintain a speed of a consistent value. And that is basically accomplished through a closed loop control system. And so if you studied control system theory, you will know that it's a lot more complicated than that. And there's going to be a lot of, I want to say, mathematics that go into control systems. But basically anything that has to do with controlling a process, and I'm using that word in the definition, but basically understanding the state of a process and applying certain parameters to that process to get to its desired state is going to be a control system. So just as a very basic example, again, if you have a tank, I've done a lot of work in the food and beverage industry. You have, for example, a level sensor, right? And this could be accomplished via a sensor or a load scale here at the bottom of the tank. And then you have something feeding into the tank, right? So this is a pipe that feeds in one ingredient or multiple ingredients. Maybe you also have a heater at the bottom of the tank, right? That's heating the entire tank. You also have an agitator that's going to be basically spinning a certain blade inside of the tank to make sure that there's movement. And you have infrastructure allowing you to quote unquote control the state of that tank, right? So you have a connection to the sensor going back to an IO rack with PLCs. You have the motor that's going to be controlling the agitator. You have some kind of a flow meter here on the pipe that's going to also tie into this. There's going to be maybe a discharge motor going to a different tank that's also going to go into your PLC. The heater, of course, is controlled by the PLC. So the control loop when it comes to industrial automation systems is basically what you're going to be programming as the state logic inside of your PLC to get your system to the desired outcome, which in this case could be mixing different ingredients, heating up to a specific temperature, and then sending that off to a different batch. So again, control systems, there's a lot more to it and when it comes to mathematics and how they truly operate. But in the industrial automation setting, to some extent that is abstracted through the use of PLCs, you're not necessarily going to be expected to be doing full analysis on the process, which is usually done by chemical engineers and process engineers that are going to be scaling this. But you're going to be programming what's inside of the brain of your platform that is going to be your PLC, your DCS, and obviously some other components that we will get into. Now, what is engineering, right? And there's going to be a whole lot of debate between engineer, technician, electrician, and operator. But at its core, engineering is solving problems for new systems and new designs. Now, that doesn't mean that an engineer is not going to be called in to troubleshoot, to help with maintenance, to help with some of the line problems. But generally speaking, engineers are the ones who will be looking at designing or bringing in new systems into the facility, into the company, and they're going to be leading, I would want to say, longer term projects. So whereas a technician or an electrician is going to be dealing with the day-to-day situation, perhaps assembling a system, perhaps making sure that the system runs per standard operating procedures, engineers are going to have a much more long-term view within a company. So they will be looking at bottlenecks and how to eliminate them. In 6 months and 12 months, they're going to be running projects looking to augment the current capabilities of the facility. They're going to look at problems like obsolescence, and they're going to create plans on how we can address them effectively. Engineers are also going to be dealing with some more, as I mentioned, project management and financials than, let's say, an electrician or a technician. And although engineers are rarely, I want to say, well versed in those subjects, they will learn on the job and they will understand those subjects typically a little bit better because they have to be communicating with outside vendors, with third-party integrators, and I want to say stakeholders in some of those projects to make them happen. So what is the body of knowledge of a control systems engineer? And again, this is going to vary, of course, depending on the facility, depending on the industry, depending if you're working or are employed by an end user versus an OEM versus a systems integrator, but the fundamentals remain the same. So number one, electrical. So electrical is a very fundamental discipline that will be required in control systems. And electrical, I want to say, encompasses a lot of different areas. So number one, I would say, and this is something that I would always interview and question people about, is safety. So safety, again, it comes in different flavors. There's safety of the machine and there's safety of the human being. And so when it comes to safety, my biggest concern is if I hire this person or if I bring them on board, will they be safe in panels where if you drop a screwdriver or if you make a mistake, you could be potentially subjected to a whole lot of voltage and current. So safety, first and foremost, remains the topic of, are you going to be safe performing the job that you need, regardless of any other knowledge? And like I said, here it's important to understand when I'm talking about safety here, first and foremost, you need to be safe working with the equipment that is going to be in place in manufacturing. So of course, then you have your component level, so components. And this, what I mean by components is, for example, your motors, your pumps, your valves. So systems that will be basically on the plant floor that you need to understand the basic functionality of. So again, just to list a couple of here, motors, you're going to have sensors, wiring. I would say networks falls into this as well, networks, but we'll get into that in just a moment. But basically you have a general understanding of systems and how they operate from an electrical standpoint. And again, we can expand on this quite a bit. You should have gotten a lot of this knowledge in an engineering degree or through osmosis if you've been in a technician or an electrician level position. But basically, in very broad strokes, you're going to have three phases that come into your factory. You're going to have some kind of a transformer, which is then going to step down. Let's say this is usually 16 kilovolts. This is going to be stepped down to 480. And again, I'm just explaining this in very broad strokes, but you should be understanding how this actually happens in a general sense in a facility. Then you're going to have a very large MCC or motion control cabinet where you're going to, again, have three phases for your different systems. As I had illustrated, there's going to be different pumps that will tie into this, right? So in general, the systems are going to look something like this in the industrial setting. And of course, this transformer can feed multiple MCCs, but as an electrical engineer, you should have a general understanding of the systems that you're working with and have a comprehension of what can tie in and how the different components fit together. So on the actual control side, right, so I've mentioned some components that you'll see in the field. You need to understand critical pieces of equipment that allow you to control machinery, right? And those are going to be your PLC, those are going to be your HMIs, or human machine interfaces. And of course, you will be in charge of programming or leading some of the projects that lead to the deployment of these systems on the plant floor that ultimately help the process get better, help the operators, and make everybody happy. So PLCs, HMIs, I had mentioned networks. So again, depending on the facility, depending on the architecture, you might be required or to some extent be involved in setting up what's called OT networking, which could bleed into the plant networks as well. But that's a whole conversation outside of the scope of this video. So those are going to be the basic components that you need to understand as a control systems engineer. And of course, if we want to touch base a little bit on the brands, so this is something that I always recommend. Again, if you're going to be in an area that's predominantly Siemens or predominant Rockwell Automation or Allen Bradley, you should be learning how to program components of that specific vendor. You can learn PLCs and HMIs through a variety of different tools. There's a lot of free and open source software available. However, there's going to be nuances in the specific platforms. And of course, as you go through and experience some of this firsthand, you will learn to appreciate, but also to some extent be frustrated, but have the knowledge of a, I want to say, more senior engineer as you start deploying larger systems, as you start working on bigger projects, as you start dealing with problems that don't necessarily just involve a single machine, but maybe a distributed system. You will start talking about SCADA and MES. So SCADA/MES, and I've done videos separately on both of those systems. I do not expect junior control systems engineer or someone who's just coming into the field to understand the nuances of deploying these systems, of dealing with them, of understanding the different flows of data, but it is something that you will be building upon, and also you will stand out in interviews if you, at the very least, spend a little bit of time understanding those subjects. So the other big question that always gets brought up is where can you work as a control systems engineer and how the workplaces are going to be different. And again, when you're recruiting, you also want people with different, I want to say, not necessarily abilities, but desires when it comes to working for that specific environment. So the usual debate is going to be between integrator and use OEM and distributor. So really briefly, an integrator is going to be a company that's going to provide integration services for an end user. So in those environments, you're typically going to deal with a lot of varying systems and a lot of different environments. So you need to be very comfortable working on different platforms. You could have projects as long as a couple of months, but as short as a couple of weeks where you deploy a system, then you move on to something else that is entirely different. When it comes to end users, again, when I say end user, it is a manufacturer of a finished product. So I've personally worked for Procter & Gamble and Kraft Heinz, and those are considered to be end users. So when you work for those environments, you usually have two, I want to say, distinct roles. You can either be at the plant level or you could be at the corporate level. At the plant level, of course, you need to understand, and you typically have a lot of technical debt, what I would call, but ultimately you have machines that have been there for multiple years that you're going to be supporting, augmenting, troubleshooting, and helping make better. So usually it's not going to vary as much as with an integrator, but you're going to face different challenges in those environments. So an OEM is basically a builder or a provider of a platform. So an OEM could be Rockwell Automation, it could be Siemens, it could be Opto22, Phoenix Contact, right? So there's going to be a lot of different OEMs. It could also be on the mechanical side or more, I want to say, builder when it comes to mechanical components that might integrate into control systems. And so those environments, again, are going to be different. So some of those groups are going to have integration teams, but some of those groups are going to be purely supporting customers. So there's going to be control systems engineering roles where you're basically in a call center answering very technical questions. You could also go the sales route. So you're a control systems engineer helping with some pre-sales questions or helping designing systems to make a decision for the end customer. Now, distributors, again, so in our industry, it is very rare that you can just purchase equipment directly off the website of an OEM. There are such examples, but for the most part, every OEM is going to have distributors in different areas, and those distributors will basically sell those parts to the end user. And so I would argue most distributors are not going to have a control systems engineering team, but some of them still do have those or provide that capability, which basically means that you could be helping end users. I would say it's more of a blend of being an integrator and an OEM working for a distributor. I know some very highly qualified people on that side. So distributors are slowly starting to pick up that capability, and that could be an opportunity for you if you're either recruiting for a distributor, so you could be looking for talented control systems engineers to help with the projects, or if you're looking to apply to distributors, perhaps you can pitch them that specific idea. So the question of work-life balance inevitably gets brought up because this is an environment where things or systems run 24/7, usually 365 with some days off on very specific holidays. And I can tell you from personal experience, I've been in environments where the only time you could perform an upgrade or any augmentation or new equipment be brought into a system was on holidays. So a lot of times when you're a new, or I want to say early career systems engineer or electrical engineer in the manufacturing space, a lot of the deployments will happen during key holidays. So it is to be expected that you do show some initiative and you are on site when it comes to those shutdowns. However, in most cases, the employers will be flexible and allow you to take those days off on a different period when there's no work to be performed. And again, the reason for that is because your manufacturer is going to be producing product as much as possible until the end of the year. It could be their fiscal year, it could be the actual year. So I would have the conversation as to when the plant typically shuts down for maintenance or for upgrades and things of that nature. Of course, with an integrator, you have a different challenge. So if you work for an integrator or looking to work for an integrator, you're going to have the question of travel, right? So if you're working for a home plant that's going to be supported by you on a regular basis, the amount of travel you will have is going to be limited. But if you work for an integrator, as I've mentioned, you could have different projects. So you could be supporting customer A one week and then customer B the next. And customer A and customer B may not be in the same city, not even in the same country perhaps. So you will have the question of travel, right? So travel varies in our industry, and usually customers are very happy to pay for travel as long as it delivers the value that they're looking for. And so basically for an integrator, it is not uncommon to see 90% travel, right? And so what does 90% travel typically entail? Well, you're doing a lot of startup of equipment. So there's going to be usually an office systems engineer or the corporate systems engineer that will design a system. And then there's going to be a field control systems engineer that's going to go out into the field and install what is or what has been designed by the company. So if you like travel, if you're looking to see new places, although I'll put a caveat, they're not always in the nicest locations based on my personal experience, that might be a role for you. The upside of travel is that most of it is usually done on an hourly basis as well as paid overtime. So usually you can make quite a bit of money. Again, whether you get the chance to spend it depending on the 90% travel or not, that remains to be answered by you. But ultimately you have different options as a control systems engineer and somebody that works in this industry. So the last topic I want to discuss when it comes to control systems engineering is education and upskilling. So there's always constant debates in our space. Can you get in without a degree? Can you start by learning on your own? Can you just get a certification to enter this field? And so I obviously have a certain bias because I graduated back in 2013 with an accredited electrical engineering degree. However, I do want to provide a few pieces of advice for anyone who's looking into this field, or like I said, who's recruiting perhaps in this field and is looking to hire individuals. So number one, I think a degree is a solid foundation. And the reason I say that is because, for one, obviously there's going to be some classwork that's going to some extent, not be applicable to our space. But I believe that you do get the fundamentals of electrical engineering theory in a lot of the courses that I've at least taken and that you should be taking in your specific degree, and that's your control systems, that could be your signals and systems, that don't necessarily, I want to say, apply one-to-one in manufacturing, but they do create that level of thinking in your head that, hey, I understand how the signals work and I can measure the voltages, for example, at these 2 points, and I'm expecting something a little bit different than what I'm seeing. So it gives you that little bit of an edge versus someone who has not learned any theory. Number two, I would look for schools that provide you with applied education, right? So schools that have labs of mechatronics or robotics that allow you to get hands-on with some of this equipment, right? So I've mentioned a little bit the PLCs and the HMIs, right? So PLC and HMI. And unfortunately, in our space, it is usually very expensive to get your hands on a live PLC and a live HMI, and usually all the associated software with the top vendors. So what the school allows you to do, and again, if it's a degree, if it's a certificate, that's not a huge, I want to say, difference, but what it allows you to do is get hands-on with some of this hardware and software that you will see in the field. So practicing the craft is extremely important. How you get there via degree, or if you go on eBay and purchase these components yourself and figure out how to tinker with them, is not necessarily the question. Like I said, I think you should be looking for a path of least resistance. I also, when I've interviewed a lot of candidates, I can personally tell you that the ones that have had a lot of interest in control systems have shown me something outside of their coursework, right? So they didn't simply list, I took a class that gave me the programming basics of your PLCs and HMIs. They had actually built something. They could show me, hey, I have a little system with relays and maybe even Arduinos or Raspberry Pis that I wired in because they were simply on a budget, but it is definitely something that stood out to me. So if you're looking to impress, or if you're looking to hire people into this field, look for projects outside of their general curriculum in the degree of their choice. In terms of certifications, some of the vendors have really good certifications and programs where you could learn and take a subject. A lot of them, I would argue, don't have the sophistication or the testing procedures of, let's say, AWS or Azure, where you have a proctored exam. So the problem with those certificates is that they can be very easily, I don't want to say faked, but they can be very easily obtained, meaning that you can just sit through the presentations and get certified. So I would argue that many of them are not worth a whole lot, but they are worth in terms of knowledge. So if you can actually get the information from them and you can articulate what you have learned and how you can provide tangible benefit to the employer of your choice, it is extremely valuable. I would not discount, obviously, YouTube. There's going to be platforms like Udemy. There's going to be really good OEMs like Inductive Automation that have a full university. And we see a lot of OEMs follow suit. There's going to be UR, the robotics company, providing in-depth detailed videos and guides on how to use their platform. So I would definitely spend the time at the very least to learn, and also put that on the resume to see that, to explain that you're interested in those platforms. but expect that the certificates are not going to, I want to say, weigh too much in your favor. So that's going to be all for this video. If you have any questions, if you're hiring, if you're looking into those roles, if you're looking for a strategy on the corporate side when it comes to your manufacturing facilities, if you're looking to build out some of these teams either on the corporate side or on the plant level side, don't hesitate to reach out with questions. Happy to help, happy to jump on a call if that is required. As I've mentioned a little bit earlier, I still do mentor multiple engineers in the field in these positions. So I definitely understand some of the challenges they're facing, some of the opportunities that are there for them, and perhaps how they should be approached when it comes to building their career and expanding their capabilities at the manufacturer side.